Okay, so as we're getting closer to the regions and the end of school, we're gonna focus in more on test strategies. So, for example, if you are looking at a circuit question, step one is determining if that circuit is parallel or series. Parallel circuits have more than one branch. So if you're going, and so we're only looking at the resistors or the light bulbs. Okay, so you're following the paths for the resistors or the light bulbs. And if you can make more than one path through the resistors, it's parallel. If you can only make a single path, then it is series. Okay, and then once you have that, you're going to use the rule based on that determination. Okay, so the question is for this one would be, what is the voltage at V1 and V2? But the first step is, what type of circuit is this? So you're determining how many paths can you make through the resistors. Okay, so now you know that this is a parallel circuit because you can make two paths through the resistors. So what is the voltage rule? Look at your reference table and determine which is the voltage rule for this one. Okay. Now you can answer this question. What is the voltage at V1 and V2? Okay, now looking at this type circuit. What type of circuit is this? This is a series circuit because just looking at the resistors, you can only make one path through both resistors. So what is the voltage rule for this type of circuit? And what is the voltage at V1 if V2 is 8 volts? Okay, now looking at motion questions. The first thing you have to determine when you read the question is determining the type of motion. Is it constant velocity or constant acceleration? Then determine what do you know, and that's where you want to be boxing in the equation. Boxing in the question what you know. Determine what you are looking for. Usually you see how long, what's the speed, what's the time, those are what's the distance, those are all going to be what you're looking for. And then you're going to determine any hidden information. Hidden information could be something at rest. That means it's starting at initial velocity of 0. Or if it is free fall, then what is our acceleration? Our acceleration is gravity. Okay, and we find the gravity number on the front page of our reference table. That's the small g, which equals 9.81 meters per second squared. They are not going to give you that in a question, but any object falling in free fall is going to accelerate due to gravity. Step 5 is you're going to find the best equation. The best equation is the one that matches up. So, and it's whichever one you're only missing one thing. So the first one is only used for constant velocity. So we only use this v equals d over t when it's constant velocity. Here, both of these equations really are the same thing. Both have an initial velocity, a final velocity, acceleration, and time. This is just written out a little bit further. So really this, the VF equals VI plus AT is a much easier equation because it's taken this change in velocity to what it really means. The next one is a distance equals initial velocity, acceleration, and time. So this one doesn't have a final velocity, whereas the last one doesn't have a time. So it matters on what information you have and what you're looking for, okay? This one doesn't have a distance. This one doesn't have a time. So, given a 6 kilogram cart initially traveling at 4 meters per second east, accelerates uniformly at 0.5 meters per second squared east for 3 seconds. What is the speed of the cart at the end of the 3-second interval? So the first question you're asking is what kind of motion this is. Step 2 is you're starting to box things. So the 6 kilogram cart, the 4 meters per second, the 0.5 meters per second squared, and the 3 seconds. Okay? So 6 kilograms is our mass, 4 meters per second is our initial speed, our 0.5 meters per second squared is our acceleration, and our 3 seconds is our time. But our 6 kilograms, does mass have anything to do with speed? No, so we can cross that out as a non-necessary information. Okay, then you're going to look for the best equation to figure this out. And then you're going to solve out based on that information. Okay, now looking at this one. While taking off from an aircraft carrier, a jet starting from rest accelerates uniformly to a final speed of 40 meters per second on a runway that is 70 meters long. What is the magnitude of the acceleration of the jet? So, question number 1 is what is the type of motion? Next, then you are going to start boxing out information. So the 40 meters per second and the 70 meters long. So 40 meters per second is our final speed, and we have a distance d. But we also have some more hidden information, right? This rest, it tells us our initial speed is from 0 meters per second. Using this, what would be the best equation to use to solve this out? And then you're going to solve it out to find the right answer, to find the acceleration. Okay, some information when you're dealing with forces, okay? Any object traveling at constant speed, the net forces are equal to 0, okay? Helpful hint is to draw a diagram to see what is going on in the x direction, the horizontal direction, and what is going on in the y direction. Only find net forces in one plane at a time. So plane means horizontal or vertical direction. We only do them one plane at a time. If there is acceleration, there is a net force. So you have to have a net force to have acceleration. That's the opposite of that traveling at a constant speed. Constant speed, constant acceleration are the same thing, and net force is equal 0. If there is acceleration, there is a net force. Friction force is anything that goes in the opposite direction of motion. And the normal force is equal to weight, and the weight is the F of G. And they go in opposite directions. So, an object weighing 2.0 newtons is pushed across a horizontal, frictionless surface by a horizontal force of 4 newtons. The magnitude of the net force acting on the object is. So, step 1 should be to draw it, because it's much easier to see what you have here when you draw it. So, when you draw a box, the first thing is you say the box, you have the weight coming down, 2 newtons. Next, I draw the applied force, 4 newtons. And you may think you have to do some math to get this combination because we have that net. But if we have this 2 newtons down and the box is sitting on a frictionless surface, there is also your normal force coming up. And this is where it helps drawing the diagram, because you're more likely not to forget the normal force balancing out your weight. So the magnitude of the net force acting on the object is, and answer this question.